single process. Okay, because we are dealing with the single process, I'm taking a single process. Let us say the name of the process is P1, and let us say this P1 has been divided into different kind of segments. Segment is nothing but different parts. Okay, segmentation means we are dividing a process into different kind of segments, because the way they are stored in the memory will also be in a different passion. That's why, for example, in we have a segment number one. Say like I'm starting with the segment number 0. Next I'm looking at the segment number 1 and segment number 2, like that. There are so many segments within a same process. Okay, whenever you are given a process or a process has entered the operating system, so if we are going to apply a segmentation technique or segmentation algorithm for the sake of management of memory, so this is the process that we are going to follow. So let us say process P1 is there, and the process P1 has been divided into different segments like S0, S1 and S2. S0 is the first segment, S1 is the second segment, S2 is the third segment, and if there are any further segments are there, they will be divided. Okay, for example, if you take a C program, so how to understand this one? If I take a C program, C programs will have a different modules. Do you know what is a module? Give me a reply. So module is nothing but the function. A C program is called as a procedure oriented programming language. Why? Because the C language is divided into different number of functions. If you ask me what is the brief overview of a C language, simply a C language is a nothing but the procedure number 1, okay, plus procedure number 2, plus procedure number 3. So what about the C++? If I go for the Java, what is the if I want to give a simple formula of what Java is, if you know nothing also, you can give this formula as a Java program will be a collection of the, okay, collection of object 1 plus object 2 plus object 3, right? Okay, so if I want to define a Java language in a simple formula, a Java program is a collection of objects, nothing more than that. If you ask me what is a C language program within a simple formula, I can say that a C language program is nothing but, okay, a C language program is nothing but the collection of different functions like function 1, function 2, which are also called as a module 1, okay, module 2, module. So that's why C language is also called as a modular programming language. Module, whether you call it as a module, whether you call it as a procedure, whether you call it as a function, the meaning will be same. So module number 1, module number 2, and module number 3. So I have taken a C program. So this is the process. So the example for this process which I am going to take, let us take it as a C language program itself. Okay, instead of this I am taking a C language program itself. So I'm taking this out. So whenever I take the C language program, okay, see here, this is the module 1 will be stored in first segment, and module number 2 will be stored in the second segment, that is the S0. In the S0 segment, module number 1 will be stored. Let us say in the S1 segment, the module number 2 will be stored, that the procedure number 2 will be stored, and the third partition, that is M2, will be stored in, let us say, S3 as the third segment in which that M3 will be stored. So let us understand this. So CPU, what the CPU will do, if you is if you want to proceed to a process of segmentation, what the CPU will do, the CPU will generate a logical address for each segment. Okay, how many segments are there over here? Let us say there are 3 segments are there over here. For each segment, let us say S0 segment, S1 segment, and S2 segment, for each segment the CPU will generate a logical address. Okay, logical address. In this address, okay, this is the logical address. In this address we have the 2 parts again. So for each segment, okay, for each segment as S0, for let us say I'm taking S0 first segment, what the CPU will do, What is S0? Segment. Segment means what? A partition. Partition means what? One of the parts. If I divide the C process into three parts, the first part is the first segment, and the second part is the second segment, and third part is the third segment. So instead of executing them directly, I'm dividing them into parts or the segments like S0, S1, and S2. And this division of C program or the C process into segments is done by the CPU. So in the so-called process, what the CPU will do first, it will divide the program or the process into segments. For each segment, it will generate this box for S0, S1. So this box is different for different segments. S0 have a different box, S1 has a different box, and S2 has a different box. This is the common structure or the common syntax for all the segments that is going to be created by the CPU. Okay. So what is this S and what is this D, and what is the operation that is going to be performed here? What is the mathematical calculation or the logical calculation? Now we will discuss. We have understand the basic that we had. Let us take a process. Okay, what is that process? Are you getting what I said? Say yes or no. Is my voice is audible? So let us go with the explanation again. So I'm drawing the diagram here. Of course, I need to draw here. Why? Because here also it is okay. I want to explain you properly. Sorry, I will take with this one. I will take two things, one over here and the another over here. Okay, this is the segment 0, this is a segment 1, and next one is segment 2. Right, let us say the segment 0, the this is what the process, C language process, so which has been divided into three segments or three modules or the three procedures. This is the part number 1 or the module number 1, module number 2, and module number 3. And each module, okay, whenever is taken by the CPU, will be called as a 0th segment, that is S0. Okay, this is S0, sorry, and this is S1, and this is S2. S0, S1, and S2. Let us say the segment S0 starts at an address 0 and ends at an address 100. Okay, and where the segment number 1 start, what is the starting address of segment 1? 100 is the starting address. Okay, this D indicates the, this is the offset, of course. This S indicates the segment number. S indicates what? Segment number. What is S? X segment number, and D is called as the offset. So try to understand, S is the segment number and D is the offset. So what is this limit? What is this base? Base is nothing but the base address. What is the base address of S0? Tell me. The base address is nothing but the starting address of that particular segment. The base address of S0 is nothing but 0. Why? Because the starting address of S0 is 0. So I can say that the base address of the first segment S0 is 0. So this base, this is actually is called as a segment table. What is this? Segment table. This is the logical address. Okay, I'm trying to explain each. This is a CPU which generates the segments. For each segment, it will generate a logical address. The logical address consists of S and D. The logical consists of S and D. S is nothing but the segment number. It can be S0, it can be S1, it can be S2. What is mean by D? D is nothing but the offset. O double F S C T. Offset means what is that? What I have told you? It's nothing but the offset. O double F S C T. So D is nothing but the offset. S is nothing but the segment number. It can be 0, it can be 1, it can be 2. So after this, here you have a segment table. Each segment logical address will be mapped with the segment table. Okay, in this we have again two parts. One is the limit and the base. What is the base? Base is nothing but the start address of a segment. The starting address of S0, that is the base address of S0 is 0. The starting address of S1, that is the segment number 1, will be 100. Okay, so let us say the segment number will end at something like 250. What is the segment number is going to end? 250. Now, what is the gap between 100 and 250? Tell me. This gap is 150, right? This gap is 150. This 150 is nothing but our limit. Limit is nothing but the gap between the ending address and the starting address or base address. This is the base address or starting address. This is the ending address of a segment. Let us take the segment S1. The starting address of S1 is 100. The ending address of S1 is 250. What is the difference? 150. This 150 is nothing but what? Our limit. Okay, so you have understand the terms from here to here. CPU, central processing unit, which generates the different segments S0, S1 and S2, and you have a logical address it is going to generate, and each logical address consists of the two parts. The first one is S and the second one is D. S is nothing but the segment number and D is nothing but the offset. Okay, so offset, you can take the offset in any way. In this particular example, I am taking the offset as 50. I will tell why I have to take the offset and what is the advantage of offset in the next step. So let us take the offset as 50, right? So what is that? You need to understand what is the limit. Limit is nothing but the difference, how much in how many bytes, in how much place a segment occupies, that is called as the limit. The S1 segment will occupy 150 bytes. What is that? 150 bytes. Next, what is the base address? The starting address of each segment is called as this base address will be different for a different segment. Each segment will have a different segment table. For S0 the segment table will be different. For S1 the segment table will be different. Why? Because the limit and base of the segments will be different for different segments, right? Okay, this process will be done how many times? The number of segments, how many are there? S0, S1 and S2. Now let us go for the S2 and let us take where the 250 and the next one is something like I'm taking it as 280. What is that? I'm taking it as 280. Now tell me, I'm asking the question to you. Okay, I'm asking the question to you. Yes, come on. Oh, sorry. Tell me what is the, okay, so take the S2 as an example and tell me what is the base and what is the limit of S2. Give me a fast reply. Okay, what is the base and limit of S2? Yes, I'm waiting for your replies. Yes. What is the base? Base is equal to how much? And the limit is equal to how much for S2? Are you replying? Give me a reply fast. What is the base? What is the base and the limit for S2? Segment number 2. That is the third segment. What happened? Yes, I will continue my explanation. Okay, Meghana, right answer, Meghana. Good. Happy for your answers. So let us continue this. So till this point we have covered. The next thing that we need to cover is how this calculation is performed, how this condition is checked, what is this calculation, and what is this plus, and everything we will discuss. Okay. So what is the offset? The offset is given as how much? 50 is the offset. Okay. So the offset is how much? 50. So offset is the what is the name that is given to offset here? The offset name is nothing but d value is nothing but the offset. Okay. Now let us take any of the segment. Okay, let us take any of the segment. Let us take the segment number 1 here and try to. So let us take the segment number 1. So segment number 1. For the segment number 1, what is the limit? What is the limit and what is the base? The limit is 100. So here I am writing something like 100. What is the base? The base is nothing but the 0. That is the base address or the starting byte address of the segment number 0. Okay. So right now we are dealing with what? Segment number 1. So what is here it is doing? It is comparing the d with the limit. What is the d value here? 50. What is the limit here? 100. So d less than limit. Let us start comparing d less than limit. Substitute the values of d and limit. So here what is d? D is nothing but 50. Less than, what is the limit here? 100. Is it or not? The limit is going to be what? 100. Is the condition is true? Give me a reply. 50 is less than 100. The comparison is something like, so 50 offset, that is d, which is less than limit. Okay. What is the limit is 100. Which segment we are going to take? We are going to take the segment number. It is looking like 166. So or else we will go here. D is less than limit, that is 50 is less than 100. The condition is true or false? See here, the actual concept starts here. If you understand this, this is the end of our segmentation concept. So uh, is it true or false? Give me a fast reply. Give me the reply. Is it true? 50 is less than 100. True or false? Yes, true. If true, what happens? And if false, what happens? Yeah, let us see. Okay. This is a 0. Okay. So the condition is true. Whenever the condition is true, we have to go like this towards the right side, and we have to add to the base. We have to add that d. Okay, what is the base here? Tell me what is the base here? What is the base for s0? The base for s0 is nothing but the 0 to which what is added? D will be added. This is d, no? D will be added. 0 plus, what is the d here? Offset is d. So 0 plus 50. So sorry, here you are going to add 0 and 50. So 0 is added with 50. Okay, what is the result? The result is going to be 50. Right? Till this point you have understood, no? So the next thing is the 50th instruction will be taken. What is the next step after performing this? Here I am explaining this again. Here we are comparing the d with the limit, that is nothing but 50 and 100 are compared. The condition is true. Always the offset should be less than the limit. Whenever the offset, that is d, what is nothing but the 50, we have chosen the offset as 50, which is less than the base, which is less than the limit, right? Limit is how much here? Limit is 100 for s0. I'm taking the s0 into example. So whenever the condition is true here, so this condition is true, the flow will go like this. This is the false flow, this is the true flow. So whenever the condition is true, we are going to add up. So what we are going to add up, we are going to add up the base to the limit, that is the d. Okay, offset and the base will be added. The offset is going to be 50 and the base will be 0. Now 50th instruction will be taken by the cpu for execution. Okay, here from S0, which instruction is going to be taken? 50th instruction, that is the main instruction that is going to be taken. So this is the process whenever the condition is true. Whenever the condition is false, the process is going to be different. What is this is going to do nothing. It will be going into a trap. See here, this is called as what? Trap. Addressing error. There will be some error generated by the operating system. There will be some interrupt. Okay, there will be a trap. The operating system is not in a position to execute that particular instruction in case if the offset is not less than 50. So if you take the segment number 2, you can understand what is the limit here. The limit is going to be 30, right? What is the offset? The offset is going to be, see here, you can see the offset. The offset is going to be what? 50. Here the offset should be always less than the limit. Okay, see here, the limit is 100 and the offset is 50, so 50 is always less than 100. For S0 it is okay. If I take the S2 into account, the offset should be less than the limit, but the offset is greater than this limit. Okay, this is 30 and this is 50. In such a case there will be an error. Okay, a main instruction will be taken provided this offset is less than, always this offset should be less than the limit. Okay, that is the, you have to remember blindly that the offset should be less than the limit, then only some instruction will be taken. And what instruction will be taken? That is that is the summation of the base address with the offset, right? Similarly, can you tell me what is the instruction that is going to be taken for S1? Okay, I have explained you S0 and S2, right? Now tell me, this S1 is there, no? For S1, let us calculate. Okay, I will take this, I will remove all this. Now you can tell me how to calculate the main instruction set taken from the S1. Okay, tell me, you have to, so this process is there, no? This total process. Okay, how to perform it for S1? Here the base address is 100. Base is how much? 100. What is the limit? 150. Is the limit is less than offset or greater than offset? And what is the offset? Always remember the offset is here I am taking it as is a 50. Always start comparing this offset with the limit. What is the limit? 100. 200 minus 100, that is 150. So is it going to pick up the main instruction or not? Give me a reply. Is it going to pick up the main instruction or it is going to be in the trap? Tell me, is it a trap or main instruction taking? Yes, tell me. The condition, you have to check the condition, right? See here, I'm explaining the this for it, so that if you don't understand in the previous S0 and S2 segment, now you are going to understand in the S1 segment. All of you listen carefully, right? Here I'm calculating the total process for S1, right? So S1, what is the limit? I'm taking this as a S1, right? So ఇంతకుముందు మనం తీసుకుంది as 0, but we have called it as S1. Now we are taking the S1. What is the segment number? 1. Okay, what is the offset? 50. Okay, sorry, 50 is the offset. What is the limit for segment number 1? 200. 250 minus 100 is 150. So the limit is going to be, oh sorry, the limit is going to be 150. And the base, what is the base address of S1 is 100. sorry, this is 150 only. Now let us check the condition. What is D is nothing but 50, right? So I'm comparing the D, that is 50, with the limit. What is the limit? 150. The condition is true. Whenever the condition is true, addition will be happening between the base address and the D. What is the base? Is 100, right? Base is 100. Okay. And what is D? D is 50. So the total result is going to be 150. So the CPU is going to pick up the 150th instruction. Okay, the CPU is going to pick up the 150th instruction. So somewhere over here it is going to pick up the instruction somewhere in between this 100 and 250. The 150th instruction will be going to be taken as the main instruction. Okay, so this is you can take the screenshot of this. This is the segmentation matching process for the segment number 1. Take the screenshot and give me a reply like yes. And this is the end of the topic.